Hello, how's it going? I'm Jun Chan. Welcome back to the stream. We're back doing some Purescript today, and specifically Purescript React Basic meets Purescript React Explorer. So Purescript React Basic Explorer. Yeah, that's a mouthful, but that's what we're doing. And that's not right. And yeah, where were we at? Oh, I see that I have two of those already. Yeah, we made something basic work. What was it? It was our test, which is now using the Purescript React Explorer way, the original formulation, to build a user pattern functor. Use that to build a co-free comonad. And then use that to derive the monad automatically using co, and I'm using co-t here, but I'll get back to this in a second. And then using these monadic values or monadic actions as handlers to react, for instance, to key up events in this example, and then render them. So, and the difference with Purescript React Explorer is that now we're actually using all of the React Basic DOM things. And that means that compared to React Basic to Purescript React Explorer, we had to, instead of UI being a handler A to a React element, we are now returning a JSX, but we're also allowed to parameterize things with props. And I believe we're dealing with props now, maybe correctly. I'm not even sure, to be honest, because it could be that we are actually re-rendering our React component at each event, which might not be needed, but it depends a bit on whether component should update and how it's done, and whether props have equality or not, all of that stuff. But maybe that's something actually I should write as something to do a little bit later. Check if props are handled and should component update works as expected in React. So I'll write this as something to look at. But then, so that was us making something basic work, and then also try to make props work, which allows us to do something like passing the label counter here to our explore counter well, combinator, or yeah, explore, I suppose you could call. Well, it's really the run. It's the run component, and we're passing props, and then we're actually passing those props back into the render function. And yeah, and so that worked fine. And what I started to do was to go back into something that was in the end one of the reasons why we went into the whole comonadic exploration up to episode 17, which was where do we put monadic interleaving inside our comonads. So the pathway I'm exploring now, which is one that I've already tried before, is to put effect here in co-t. And that leads to a type error of wrap free not having the right instance. So let's see whether we can address that. But maybe before I do that, I want to go back to what has led us to use co-t, and that is Phil Freeman's blog post. There's annotation on this page. Interesting. There are annotations on localhost. this can really change data. Okay, sorry, that was a bit of a random thing. I want to add a few extensions that I usually use. Quick tabs. Is one that I was missing right now. And I usually also, manage shortcuts options. And shortcut key manage Chrome directly in Chrome extension shortcuts. Okay. Let's hope that's the case. Yes, activate the extension. That's what we want. That allows me to do this and then go to tutorial blog and not stack safe. Maybe it's not here. I want co-effects. Yeah, no, maybe it's not here since we've moved from Firefox to Chrome. So let's go to Functorial, a blog, and then co-effects. So that's what Phil calls co-effects. There's some confusion over whether that's actually the same term that's used elsewhere, but I won't get into that. And so co-t is about being able to return an MI. And so that should allow us to return, and that's sort of the main idea here, is to be able to express comonads in a base monad such as IO. And so that's the type of it. So co-t, instead of getting past the co-t constructor. So let's go take a look at the co-t constructor. Co-t constructor takes this a function from a comonad that contains a function from A to MR and returns a to MR. And that's just a way to build things. And it, by the way, it doesn't expect the W to be a comonad here. But if it is a comonad, then we can just extract A to MR, pass it an A, and we're golden. But what do I want to say? So I think that this will mean that here we want pure in order to make the type check. But right now we still have a type error because we're missing an instance that allows us to use wrap-free. And specifically, the instance I believe that we're missing is a pairing instance. Oh no, it's yeah, no, it is. It's a monad-free instance for co-t counter interface effect, paired with co-t co-free counter interface identity. Right, okay. So that's actually me making an error somewhere in the code here. That's not actually really an instance missing. So great that I saw that. Let's fix it. It must mean that I just have a co right here. And so you're going to call this co-t effect, and things should be getting a little bit better. They are. And right. So now we use unfold co-free. Okay, but it's because of the type of component. Okay, so we need to change the type of component. Yeah, right, because we need to put an effect in the component type. So this is actually not necessarily the best error here. I believe this is what we want. Right. I think I defined component here instead of importing it. Or is that what's going on? No, it's because I do React Basic Explore. Yeah, no, that should be all right. So is there something that doesn't compile here? There is. Okay, right. I see. Yes, so it's not just the wrap-free that's a problem. It's just that my React Basic export doesn't compile yet, so I need to fix that first. Okay, that makes sense. So what we're trying to do here is to use runCoT. And so let's try and compare runco with runCoT. Runco takes a code WA and a W of it and returns a nut. Yeah, so I think we are returning an MR here. And what I was saying, yeah, before, what I was saying yesterday is that I think we're going to need to use distribute, because I think that with this way to basically take a comonad full of something that we, let's say full of monads, if I want to have effect on the other side, then I need to distribute the monad over the comonad. And that means that I have a pairing, but I know I do have a pairing. No, I need a pairing between, I know I have a pairing between CoT W and W, but I don't know. Yeah, I don't know what the pairing I have with yeah, I don't know if I have a pairing with M and how that even works. So let's look at what we have here, because I think this is sort of where we're heading, but this is with free T and co-free T, and I think we need something similar with co and co-T, I think. Right, let's see, maybe could it be in class? Free T, co-free T in here. We don't have co and co-T related pairs, which is a bit strange. You would expect that I would have that. So, oh yeah, by the way, here I'm using the non-type class version of CoT, which is probably not, I mean, I'm not sure that's the one I want to use. So I suppose I could try and write a comonad and co-comonad pairing. I don't know if that would help me right now, because what I want is distribution. I don't know if it's pairing. Let's see if I could find out what kind of A I would need here. So set states, right, okay. So set states is an effect unit. And yeah, I think this is one of these cases where I want to do something with okay. I believe with this, something like that, no? Okay. Ah, yes, okay. But the M, there's a question about the M being effect or not here. And I could make it effect. It would be convenient. Then I could look into how to make it half, which is, I think, what I really like to have. Okay, let's try that. Let's make it effect. And now you see, actually you're compiling, right? So you're saying, yeah, we don't need to know that there's a monad here. And here we need effect. How's that? And then this hole has now this incredibly crazy type. Holy moly, look at that. So it's in a comonad. Wow. Okay, let's use const for now, which I think is the original, or was there originally. And what that does, so first of all, it's the m that we're, okay, yeah, I remember trying to do this before. I think we're trying to get an m out of, or an a maybe, out of the m. Meaning we're trying to run the action and trying to, out of that, get the comonad. But in order to do that, we do have to run Coty with the m that has this. So maybe, but with a function that returns an mr. Okay, so maybe we run it with identity. Run Coty m identity. What's this do to us? We need to import identity. Import data.identity, I think. And yeah, because we want it to be, we want to lift identity. So it's really, is it pure identity? Or it can be our identity, I think, as well. If we wanted to have arrows. Do you know about arrows? How do we lift this? Run Coty, takes an m, takes a w, I see. So I need to maybe use the identity comonad. That starts to be weird. To just get the a. Okay, let's try and make it as a lambda. So we have a w that's being passed. It's a WAMR. And we return yeah, what is the a that's being passed to us here? Yeah, I think the problem is that we're creating a comonad with functions that are waiting for their continuation. I'll be back. Okay. So it's this double inversion of control thing that is hard to reason about. Because send gets put inside the comonad. Being passed the props and the send are waiting for the next props and send on render. Let me get the original version. Explore. And that's the original version. Oh yeah, no, that's actually the version from Arthur Xavier. Purescript, React, Explore. Boom, boom, boom. Yeah. So send, which is handle here. Waits to be passed an M, which was when it gets passed, just modify the state. Writing the next step forward. Such that it just re-renders and put now this state. Re-renders with the state waiting for the next action. Yes. And now the difference is that we, instead of receiving a co-W unit, receive a co-W effect unit. And that carries its own effects, hopefully, which I'm not still 100% sure about, by the way, because it could be that I don't know whether that's where we want the effect to be. Because this is really, this is the kind of the concrete comonad, I think. That becomes the content of the co-free comonad that we're building. So it is really the interpreter. I think we should call this interpreter. And I'd like the interpreter to be effectful, but with this approach we can't, because in this approach we've made the monad effectful, but the comonad just stays pure. And yeah, I don't know whether that's the right approach. Meaning, I don't know if it makes sense to have effects being laid out here. I think I'd prefer having effects being laid out here. Which would mean that my function is from an S to a functor that maybe is in fact composed of my base functor and effect, which means that we return a co-free of that. Interesting. Okay, hold on 1 second. I wonder whether actually this works. If I say this, render in fact would stay in co-counter, I think. Component, oh yeah, we still haven't. Well, component in that case, yeah, would stay like so. They would just run co. And we need just to import co. I mean, we could say coti w identity unit, because that's what co is. And then we need to import run co. Okay. So maybe we import co and run co. Makes things more terse. And what's up then? So render we're taking a component space, which does have some. Do I need this? I don't think I do actually. I think this still works. Hold on, maybe I don't know if I'm misleading myself here, but actually this compiles, so that's not a bad news. And then yeah, I'm not sure that that's good. This also just compiled, but what I wanted to do, yeah, I do explore counter in the end. So if that's not happening in some monad, then it just doesn't work. if I could use hooks here. Okay, so I backtracked, but I kind of lost view of where I was heading. I think I was a bit misguided here. I thought I could have at the top level component here being in effect, have my interpreter be effectful, which in my mind was something like saying compose counter interface effect or something here, which would allow me to make this effectful, which I think is the place where we want that. Because that's where we would do things like persisting or writing to the database or something like that. Not reading though, which is an asymmetry that I'm not sure will work for us. Maybe with hooks it will look better. I don't know. I'm just thinking about like a reactive database, a database that would send us notification when if we subscribe to a query or something like that. Then how will we receive a handler for that to move the state forward? Not clear. No, I think maybe it can work. Yeah, maybe it can work. It just means that we install a subscription, an event subscription, or an observable, something like that, which hooks into a database subscription, and that calls a monadic action like increment, which would change the state and display the proper count. Yeah, I think this makes sense. So therefore, it seems like that's kind of what we want here. This, by the way, I think ends up meaning something like this, doesn't it? And so therefore here we do need to distribute again our effect out, and so I think that means sequencing again. But for records, so we need to pull out something that will have pure here, and maybe that means f mapping and returning pure. Right, it needs to be pure of that, which is not great. Is that true? No. I mean, I suppose if we do pure here, it should work, right? And then we can figure out how to do this next. No, it doesn't. Right, because that's counter interface of effect, not effect of counter interface. Yeah, so it sounds like, well, doesn't it, shouldn't this just work? Oh yeah, it does work. And then the problem is though that of course now we have effect, and I thought that, well, if component had effect in stack then it would work, but now I'm not so sure. Because where do we put the M here, right? And if we say there's a Coty here, then I think we're back to having to allow render to be in Coty, and maybe that's the way to go, but couldn't make it work earlier. Okay, let's think about it from another perspective. If Explorer returns props to JSX, then none of that is actually in effect. So WTF, right? Meaning, in effect, counter is just a pure component. It's not even a pure component. It's just JSX, so it's not a component. And therefore, where the effects occur matters here. So let's go back to exploring a little bit our React Basic stuff. So is it going to be React Basic DOM, or do we want React Basic Classic? Render does execute render prime. Given effect is run once. That's a cleanup effect. Something that's done post render. This effect here. So everything is a little bit made more confusing with the fact that, of course, React Basic and React Basic Classic and React Basic Hook all use the term component, and we're using also the term component. A component is not a valid React component by itself. We'd like to use React Basic component from JavaScript, use two React component. the component spec. The GSX and then just the render, which take the JSX. That doesn't leave, to me, it sort of means that effects need to occur well, basically, I'm not sure about JSX being itself in effect or not. Being able, can JSX, no, that's just, so it's rendered React VDOM can be appended. So in theory, until we start squeezing in effects somewhere, then our component, if it returns JSX and explore returns JSX, then I don't think we can make it effectful. Basically, I'm thinking maybe we need to render inside explore. So we'd render here, and so explore would be something like attach, and we'd attach the counter to the container and pass it a prop, and in theory that would allow us to run, to return, to be in effect unit, and to therefore to manage effects somewhere here. Yeah, no, that's not the right way to see it, of course. What's going on is that certain part inside the component, meaning inside that JSX really, are instruction that can be ran into effect unit later, including render. No, render really just is JSX. So, but then how, when I pass send, how do I manage to be in effect then? Is it just because set state can be effectful? It is, right? It's because set state can be effectful. But that seems like that's not where we want to hook for interpreted actions then. Okay. What does that mean then? on key up, we call handle. Let's call it send again. We have handler. We call send. And I think then we are able to run effect unit because the onKeyUp handler and the handler itself allow us to be also to be passing something that's going to be in effect unit. So we know we want to send some monadic action, fine. We're saying it's pure, okay. But then if it's pure, then after we send it, we set the state, we advance the comonad here. The moment we advance the comonad, we are passing it to interpreter here. Meaning if it's increment, then run co should be matching with this. Thread the state. Partially apply it somehow. And give us a new component. So if run co, I mean, okay, extend const state. I'm still a bit fuzzy where the actual matching or consumption of the monadic value by the comonadic interpreter occurs. Still a bit unclear about that. Maybe I should debug. I don't think I need to debug. I think I had that almost figured out. By the way, I think that was the case in not there. Script React Explorer and React Explorer Xavier. Yeah, not that. I think I had this in one of the playgrounds. So either playground or composition POC, maybe more likely. Yeah, here. So run co m extend const state returns a new component W, which gets put inside state. And the way it does that is by taking the co and then waiting for a W of A to R. And when we do extend const WA, or extend const state, state is the current state, and where we do extend const, we transform an extend, passing it this const, and we make this guy out of it, such that when we pass it the WA, which is of this shape already, because component W is of the shape of this to handle to r.react element. We're actually passing something that goes from a WA. No, hold on. That's the A. Really? Oh my. So what did I say here? Passing const allows co to have the A to R shape. A to R to R. Right, so the idea is that this is a W of A to R, with that being the A and that being the R. Is that right? Right, that's the R, right? So W no, that's not exactly right. No, hold on. When I do extend const, what I get is a WA to WY to WA, I think. I get misguided putting this here. So I think this is a result of saying, well, I extend const, which means that the passing x to y to x as the WA to B means that I take the WA to be x, the y to be B. No, that's not it actually. Oh god, this is complicated. Extends waits for a function. A function of one argument that returns a thing. So if we want it to be one argument that returns a thing, then W needs to be x to y. And I think that is the case. B is x to y, and x is WA. Which I think is what I chose here. And so if x is WA, then we have WA returning y to WA. I'm taking WA and returning a WB, and since B is x to y, or y to x, and that x is WA, then it's W of y to WA. And so I think that's fine, but then the consequences that actually extend const is this. Meaning it's now waiting for WA so that it can return a W of a y to WA. Y being what? Sleight of hand. Being anything is the weird part about it, because with const we really, y could be anything, we don't care. So it just happened that then when we unify with waiting for A to R, then we say that A is Y, or Y then gets typed as needing to be an A, because that's what will jive with run co. So it turns out to be WA2, and then R turns out to be actually WA. And so this whole thing really turns out to be something like that. And hold on one second. Isn't that cfix or something? It's the reverse of it. W of a WA to A, right? W of a A to WA. And those are not there. Interesting, right? It's not a fixed point. I suppose it's something that consumes instead of generates. Not sure. It makes sense. Maybe something that builds, actually. Yeah, it's something that builds the comonad. So it's more like unfold, co-free, and that's that stuff, right? Build. Where are the builders? And by the way, yeah, this is comonad, this is not co-free. So that's why I don't have a generic builder here. Okay, what does this give me? First of all, I'm going to get this into our current project because it is not easy to understand. And we need to be reminded of it. So let's try and say it again. Run co takes a co WA and then some particular form of comonad that's going to yield the next one. It knows how to apply the A that's hidden inside the co WA to get a new WA, and then to use this would need to use a monadic join to work correctly, wouldn't it? Because it sounds like, oh no, because we can always extract. So actually, no, that's super easy. If we have a W of WA, we can extract, get the WA, we're done. We don't need to have join. Okay. So what am I trying to do now? I'm trying to maybe put an M here. Is it really what I'm trying to do? What I was trying to think about was how does the value of CoWA gets actually consumed by the comonad? And I think what we find out here is it's really through the extend. The whole const runco I think it's all ceremonial. The runco really is only, I don't know, runco does a little bit of work. Let's see the original. No, the original runco. Let's find the original runco. Oh well, I think I closed it. So let's try and find it here. It might be in pairing. Yeah, it must be in pairing. Cool. Yeah, I think the original run code just unwraps co. So it's really not much. But it's just the essence of co itself, that it has this kind of CPS style, which I think is also the co-density or density transformation. And actually there is pair co here. So I really don't have. Did I really not keep that? I have not. But that's yeah, that's in a more recent thing, but still it's a little bit strange that I have not kept that. But also I think I want to move into the class-based version again for this. I think it is a better formulation. Okay, let me write this down into the log. We're back to the class pairing. That will help just for legibility. Until then, I suppose I could just add pair co to our pairings. It is here. So I suppose we could use it if we needed to, except that yeah, there's no pair co adapted to co-t formulation. I still don't know whether I really need co-t. Although to be honest, I really don't see how I'm going to not be using that. We're running effects here, but it feels a little bit weird to use the set state and the fact that that has the possibility to do effects in order to run all of our interpreted effects. Yeah, I think I can get over that. It is a crucial point in the event loop, so. And then run core, which is really just an unwrapper. It's really through the extend that we take this that is now a monad, we run it with a comonad that's built in such a way that it's waiting for the value carried inside. Which in our case is the extend of the co-free comonad, right? Well, it can be any W, but in practice for us it is the co-free comonad. Which of course adds a little bit of difficulty to how we're framing this because of where, where the effect is declared. But thinking of it just as a comonad is, I think, also interesting. So have a core WA, and we can get a new WA out of it, which is really the key here. In fact, it's if what we have as component W is a component W that is partially applied, then the moment that we extend const state, we fully saturate it. I think that's where we actually pass it the value and get it into a state where is that right? Yeah, I think it is right. It's like when we extend const state, we're saying take the WA, extend const such that we transform into a W that's waiting for an A. But it's really ignoring that A. And in fact, we're passing unit here. So it's also really sort of whatever to WA in reality. So it's really just to get it in the right shape for run co. Because we're passing, which is I think what I yeah, to have the AOR to our shape, then it's almost like we trick the comonad to kind of return itself, so that it just has the right shape for Runco. But I think there should be a pattern that abstracts that sort of move using M and then doing extend const of a W. Let's see if we can do that. Let's say that move, so co W unit and a W whatever, and then return the W whatever. And we're saying move MW equals run co M extend const M W. And then we're saying move M W. Okay, well, does this really compile? No. Right. And we don't have a W here, it's state. Kind of compiles. I think it's because of the return type here. Yeah, I think in practice we have a component W here, so, or even a component W props, I think. Yeah. So that works. And that's the fact that our comonad is the thing that's full of this CPSC thing make any difference in the move? Not so sure it does. W being a comonad. Could this be for any A? Does this work for all A? It does. Is that what Arthur Xavier ended up doing? Did use this move. Yeah, that's it. It's written differently, but and I think you get this here, right? Yeah, and you wrote it differently though, and it's written as this. And obviously it's the same, it's except that, yeah, so instead of the pairing we use co, and then we unwrap, we switch WA and then we have an M, and we don't need W here for the comonad because it's defined at the top level, and we have the same thing. And so that's another way to write the same thing. Yeah, well, let's see whether we can replace that. And which pair is this? This is pair co. And we can get it. Maybe. data functor pairing co. Ah, okay, it's not exported. Right, because I can't write because I don't know how to write pairco for, or whether pairco t actually even is something that makes sense. Okay, so let's see whether I can make this work or not. Hey, Chaotical, good to see you. How's it going? Doing some streaming today? Right, yeah, so let's verify whether I can write pairco with this with the co-t thing. Doing well, excellent to hear. Yeah, I'm good. No streaming for you, all right. Yeah, that's good. Making breaks is a good and healthy thing, especially for family. Second up fennel, so you can do a weird stream next week. What is fennel? Fennel. I suppose it must be a streaming thing. Streaming graph partitioning. Is that what you're setting up? A Lisp on top of Lua. Ooh. Huh. You're leaving the world of strong types for a bit. Oh, I see. Doing some tooling things, huh? Yeah. That's a good rabbit hole to be in. Good. I'm glad you're offended by that. That's where you see the real the people that drink the Kool-Aid, right? The strong types and can't live without having a healthy fight with the compiler. Yeah, definitely one of you with that. Pairco has been defined multiple times. Is that true? Did I actually, in fact, have a pairco here somewhere that I? Oh, maybe I did. Oh, I did, and actually, yeah, it might just work, in fact. So hold on, I just need to import it. Where is it not imported? Who knows? Boom, and then that should actually fix this now, right? Yes, and then does this compile? Well, it would if we had command duplicate also imported. So let's do that. Duplicate. Hey, then we have some weird stuff going on. Okay, well, our pairco. Let's check that our pairco has the same type that we want, because our pairco here ends up having type blah. And let's write this down here and explore, I suppose. And right, and then the crazy type there means this. So it means I give it a function from A to B to C. Which in this case is a constant entity, an m. Yeah, okay, so indeed here I just need to move, duplicate an m. And then we have unit that's bothering us. Okay, I think I did that before, but probably not a bad thing to try and redo it. Maybe it's because it works for any carrier type. Yeah, it's more general, I think. But then we are actually having a type error here. Right, so definitely a problem here. try to do pure here. Yeah, no, that's the same thing. What's happening here? So maybe it works only for a different type. Let's see what surrounds the use of move in UI here. So right and move space M, being given an M, which is in unit. So that does sound like what I want. Being given an M. So what was your problem with unit exactly here? You type WA. Taking an M. Okay, let's double check with which pair co I'm getting. Data function pairing co. Here I'm not exporting pair co, so I'm getting it from trans. And here W. We could W, but let's actually get pairing in scope here just to double check. Do we have everything right? Okay, pairing is this. So if I pair W with co W, yeah, that sounds totally right. Yeah. Oh, interestingly enough, yeah, that move actually requires that W is a comonad. Whereas, oh no, but this one did too, yeah. We have W comonad here in scope. But I think so maybe it means that we can only move a comonad, which makes sense. We can pair can pair any functor F and co-F, but moving only makes sense if the F, or if the co-F is, if the co-W is meant to move a W somehow, which then is using extend or duplicate, I think. So maybe it's the const identity that doesn't work any. Yeah, I think I remember that. That because I moved the M and the W around, const identity just doesn't work anymore. We need something else. And I'm 100% sure that I wrote this before, so now it's time to actually go fetch it. Was it in comonad playground? No, it was probably in comonad composition. And data functor, where would it be? Not here. Let's see. Let's search for move. Yeah. Maybe not. Maybe search for move in SRC. And we have move left and move right, but yeah, so it might not have been where I did the refactoring, because here I use run co, and here I do use, yeah, I use explore state, right? Right. Here I don't use the move. Okay, well, it just flips. I just need to flip. Let's be bold, or not bold, but a little bit more courageous. I think probably just flip, or maybe flip const identity, or not exactly. So maybe flip constant entity. No. Maybe flip and then constant entity. Still not. How about just this? Oh, well, yeah, this compounds. Okay, good. So I just don't know how to do this 0.3 star here. Probably not too far. This should work in principle, but it doesn't. And neither does this, but this does. So, oh well, a little bit above my my skill. But we got it to work with this different version of move, which is pretty nice because I think it highlights something different, I suppose, which is the pairing, and then the fact that we duplicate W, and I mean, to be fair, let's try and write this as a F. Let's try to write it as a lambda. So we know this, and we know what. What's the type of this, actually? Could you tell us? This doesn't work, does it? No, it does. Oh, wonderful. So really, we want to say this. So really what we're saying here is basically sort of take this, ignore this, and return this. That's really what we're saying. Yeah. So nothing too fancy. Okay, yeah, sure. Nothing fancy at all. So, okay, again, what are we doing? We are supposedly we're moving by duplicating W, so putting a W inside a WA inside all of the W's cells. Then we're pairing that in such a way that we take the WA in each of these cells, we pair it, and how could that even work? How does M do anything here? How does this even work? I mean, I think extend const here is pretty much similar, right? Because we use const, so we ignore things. So one part of me wants to say, well, yeah, we just use M for its effect, but here M is a pure value. Let's look at pair co for a second. Pair co. Run cos of COW, which is RM, which is run co RM, and then map F to W. Yeah, right. Okay, so yeah, of course. So the run co is the thing that actually gives the monadic value to the comonad, I think. So let's look at run co again. It unwraps our co, which in our case is going to be this co. It unwraps it, and then we get that comonadic value. No, it unwraps it. So now it's something like that. And then we pass it this WA to R, which is the monadic value we're expecting. But what has M done at that point? No, M has just, yeah, M has given us the monadic value. So it has given us this. So maybe I should have this as an example of an M around. So when we're saying move here, move MW, or let's say move inc W, then we're doing, well, we're doing run co inc extend const W, which really means the co, the whole thing there. Apply to extend const W. Actually, without the co, that's constructed already. Apply to extend const W. Right? Right. And I think doing it from pair co is actually less interesting because pair co then does it in function of run co, so that won't clarify things for us. But okay, so now we have this. So, and this has some, this has the current state, right? But really, we call this state, but it's really our component. And so really our W in our case is this crazy props to A to effect unit to RJSX and whatever, right? So let's write that somewhere for us. Our W is this crazy thing. Okay, so 1 second. Here I'm doing a slightly different version of this. So am I here? I'm expecting, I gave it a co WA, which is this. It's a co WA. Video co W unit. And a right, a W of here a W of A to R, which we said is really a W of A to WA. So here is where we have our W of A to WA. But our core W unit in itself is something also pretty funky, right? Our core W unit really is this thing. It's really something that waits for W of A to R in order to give us our R, which is exactly what we end up giving it, a W of A to WA, and so we end up with a WA. But how does this work? In practice, it works by saying that, so we pass it this extend const W, so we're waiting for, I think, an increment that is of A to R and yeah, I need to be careful because co-free here plays a role. The fact that we co-counter interface rather than co-counter matters quite a bit here. I think we could try and write a co-counter. Let's make this type check again. Can check our type checks. Let's see whether we can run it. That's not what we want. Blah, and let's see whether we have control over it. We do. So it does compile. Yeah, what I want to try is, can we do like a thing, which is a co-counter unit, and that is going to be co of basically counter interface increment change count and return what? Well, we pass a unit to, not to both actually. How does this work when we do change count here? Change. We pass count. Where do we get count from though? That's, oh, right. We do get count from here. That's so thing is not really going to be a thing then. We can't really co-counter unit, can we? I mean, let's see whether the type checker says maybe we could. Right. Yeah. First of all, indeed, we need to build a co-free, not do it from co-counter interface. Interesting. But I think this doesn't make sense. Oh yeah, no, or rather it does, but it needs to choose again. It needs to be it would be something like ink prime, and we need to choose that I pick increment and do increment unit, and then I need to somehow build a cofree from that. And that, I think, how would that work? Show me the comonadic things. The cofree things, actually. And I just need to make a cofree, I suppose, but I'd be having to somehow kind of repeat that thing, right? So if this is a F, then I would do what? I would, let's say, make cofree. Oh, well, when I do unit this, that work? Cofree, blah, blah. And what would I need to do? The co of the cofree somehow. That doesn't even make sense. Have an infinite type. Yeah, I think if I need the F, if I need it to be, yeah, I think that's not really this, right? Right. So here I would get, okay, let's look at the type of code again. Yeah, hold on, let me get this back. Let me get the type of code and say that our core will receive, it needs to be a function like that, works for any R. And instead of getting our base function, you will get a whole cofree here, right? So we get like a whole W or cofree, a whole cofree, and then we sort of need to take I suppose we could extract, because we actually have a comonad. And if we extract cofree, we could just also use the head. Maybe using the head is fine. So maybe we do something like well, I think we need to do something like let counter interface increment equals head cough in in increment unit, something like that, with the head being the Kofri head. If you can find it, yeah, that guy. Remember your head. Okay, you do have head. What's you still compiling? What's happening? Equal head cough. Yeah, that's what I'm saying. What's your dealio? Head. And you are still insisting that you don't know head, but I have head from here. And I'm saying do head cough. What am I doing? Do I need to case head cough or something? It doesn't make a lot of sense, does it? Okay, I'm not understanding what's happening here. Ah, okay. Damn, it's not good. Okay, I think this works without races, and now we have what? We can't match because head cough is a function. Why is that? Oh yeah, because it's a function of A to R. That's right. So is that where we say this? No, that doesn't sound right. So you're saying we can't pattern match yeah, hold on, kind of makes sense actually. Well, it's not really head, it's I think it's tail that we want to pattern match, in fact, because we want the F, and yeah, so tail, and then we'll need to get the Kofri version, that guy, and that pattern matches. It looks like, but now what? Increment should be a function. And now you're trying to do what? Trying to return an R. And increment. Right. Increment really is a Kofri FA. So if we want to get an A, we maybe need to do head on it. Holy moly. Sounds like it actually did compile. Yeah. Okay. Can I even use that? So in theory, I should be able to use that here. And meaning that I don't need to wrap free. Is that true? And maybe even can do this. Yeah. And then, well then, show me that you actually work. And it does work. Well, so that's cleaner, and that's a thing. I mean, this is not easy to write. There must be an easier way to write it, but okay. That's a little bit of a detour. Kind of get lost, but I suppose I also learned that you can write ink as ink prime, and then you don't need to wrap free. So that's kind of maybe that's kind of neat. I don't know yet. But that's definitely not what I wanted to do, and so I was trying to understand how, how the value get past 2 cents, and I tend to forget that it's wrapped free per unit. So when I send this, the move gets this M, which is really something more akin to ink prime and not ink. And so it's not really this counter interface increment. It looks more like the version I just wrote. And because it's passed to extend const W, and that W is this crazy thing, which is something we shouldn't forget, and therefore I'm going to remove that like that, and make sure that we know that the W we have here is this crazy W. In fact, there is a W in front. Worse than that, in fact. Because this time our carrier value, which I'm not even sure where it fits these days. Yeah, we don't have props, but co of W. Yeah, the carrier type is HWA now, which I think is here, and only here. But this confuses things a bit, for me at least. Okay. Runco is not the thing that does it. Runco ink is this unfolded thing. I think it's actually more useful if I write some version of what I just wrote, because we are waiting for a whole commona, for a whole co-free to be passed. Waiting for a whole co-free to be passed so that we can tail on it and then do a whole bunch of stuff. It's kind of a cough. and dot dot dot. But because we have a W of this crazy thing, I think where we end up with that's really a component W, right? But since we are really want a component W of A2, to be honest, component W A. Then in fact here our W has, this is going to be the A, and it's going to return a component W of that same thing, which is a little bit insane, but that's what it is, I think. So what does that mean? I wonder if I could write this in terms of extract and duplicate using the co-free. It's possible, because now I'm thinking, okay, so we get past this W value, and in our case we take the tail of it because we know it's co-free of some G or something. By the way, this is really component blah, but yeah, we could actually say returning a component W here, and that would be correct. Oh, no, it wouldn't. Yeah, like that. The W of this, yes. Okay, so let's not see this as the implementation. Let's see it as a W of A_R. Then when we pass this W of this crazy thing, it knows, okay, it's a W of A to WA, so it's going to return a WA. So it's a W of A to WA. So from that whole thing I can get a WA, a new component W. Which we assume is the next one. And how do we know that? It's extended. When it's extended like that, I really wonder whether it's actually extending all the cells with that same CPS. Now all the cells, and I think it's actually, again, here it's probably unit or anything here that gets passed. Anything that gets passed yields a new WA. And I suppose that this says yes, anything that gets passed yields a new WA, but I'm going to tell you how I'm going to yield my new WA. And I suppose this is what this does, right? Yes. By saying something like, you give me some co-free, and I return to you okay, I need to look at what co does again. Co. Co is something that if you give it this monad with that continuation thing, then it does know which monad to give you back. So it kind of makes sense to see this as giving you back a WA, right? Because that's, in practice, that's how you're using it. And so if you give me a monad full of that, which, and I think we're saying in practice it's a monad full of that. So we're saying, take your comonad, and maybe the whole tail and head shenanigans here don't help to understand. Are we saying, take that comonad, and in our case, we know we can deconstruct that comonad. Because we know it's co-free. But then if by deconstructing that comonad, if this thing actually knows how to deconstruct a comonad and give us the next comonad, which is what in fact this does, and that inc also does, which is, except it does it for the base functor, which is like, if you give me a value in the base functor, then I give you the next value in the base functor, or something like that. Right. Remember, this is actually almost doing nothing because we still need an interpreter for it to actually do something. And so this is basically only saying like something like select the increment branch or select the increment part of the product and do something with that and leave the other one alone. And then it's only when it's interpreted that actually something occurs. And the interpreter really gets ran on re-render with the new value that knows that increment's been selected and that therefore kind of triggers increment in some ways. I mean, this is very hand wavy. Or maybe one way to say it is that it actually gets past this, and then out of that increment is selected, and then only increment is ran, and the increment gets past unit. Well, yeah, it's a little bit more tricky than that. Increment is selected, and therefore increment in the interpreter actually gets executed. So this reminds me of the very, this really only selects the function that will be ran in the interpreter. So I basically, yeah, it's very mechanical. It's not doing anything. This ink is just like a flag, basically. It's just a label. It's just something that allows to thread the commodic value in such a way that it knows that it needs to target the increment part of the tuple, or the record in this case. But the real work is done by interpreter. And therefore by unfold code free. Which takes the starting state, something that knows how to get an A, and something that knows how to interpret an S into an FS, and we'll build the code free out of that. And I think I need to go, and I think this uses the state. Well, no, it doesn't, but it's, what is it? Explore. Let's see, my playground, not the playground, the composition POC. I tried this different style. Right, this one, I think. Actually, I didn't maybe keep it, I don't think. Oh, that's kind of sucks. Okay, no, I'm not sure it matters. I think it's like the build code free, which is how Arthur Xavier does it, basically, if I remember correctly. But I think build code free is fairly similar to unfold code free, right? Yeah, it's just at a slightly different level, and I think yeah, it's explore that thread's state using that tuple in order to do the thing, and that's the similar thing that occurs with our explore, except that the state is now threaded by React. Okay, fine. We're supposed to already know all of that, but so if ink really is only some form of selector, and that really it's in this concrete commonad that we want the effect to occur, then could we say something like effect counter model here? And what would that mean? And then the other, so it's basically composing counter interface with effect here. So first thing first would be to make these types align, except no, and there would be around making first these types align. Or maybe this type align, yeah. And then we need an unfold co-free that can manage an M. And let's go check out Haskell there for a sec. Co-free. Unfold M. Yeah, I think that's what we want. And that will return an M of co-free, which would basically be a, what would it be, an M of component? Or, well, we need component to allow effects. Like there's really not a lot of, I don't think we have a way around that. Hold on. I'm saying this, but maybe it's not true. Explore returns the JSX. The whole question is, when do effect get interpreted? And in some sense, we are kind of saying we want React to maybe do that for us. And so we were saying earlier we can do this maybe in the render, but that's not a very Reacty way to do things. Normally you do something like that maybe in let's say component spec here. Do something like that and maybe did mount. Well, it depends. Like, what is our example? Let's say we want to we wanted to subscribe it to a counter is one of our examples, and then persisting something or like writing in a database as well, right? So I think the state aspect of this is maybe more interesting for us, like GraphQL or something like that. So when would we do that in practice? Well, so let's think about the life cycle here, because our thing is a little bit weird in terms of event loop, right? We when we click, it goes into this send, which does set state. So ideally it's before this, even before set state. That we want to do effects here, I think. Okay, we might want to recover from an error. In that case, that might impact how we set the state, maybe. I think with hooks, it will be maybe even clearer what the patterns should be. so I think that would be, like, say, the quickest, because that's before, like, the user would do the action that would pass a value into the comonad, so execute the handler, and then before even writing down the next step, we would be trying to execute an effect. I think that makes sense. The other option would be we execute our effect, and then on the next render, but that doesn't feel right. The problem, though, is that we can do effects here, but I think it means our component needs to be in M. There's really, I don't see a lot of options apart from making this be in M. Which sort of mean like making the whole thing be in effect, to be honest, which is a bit weird. We could make this return in effect. Not sure it helps us. It might help us, actually. This return is in effect. Let's try that. Let's say props effect that we're returning in M here. So in this case, the component is now returning the wrong thing because we need to actually return it like so and do pure comp. I think, is that right? Sounds weird. No. Oh no, actually, yeah, no, that's, we can't have render be in effect. So we'd have to do it elsewhere. So not here, but then we have our handler, so maybe we just continue thinking a bit more. I mean, I know I could do things here, right? But I don't want to. I want to do them in the interpreter because I want to be able to swap interpreters. I might be wrong with that. But I want onKeyUp to be kind of very automatic. It's about triggering an action, and really what the action does, I want it to be defined in the interpreter. And I think that's very fair, I think. Okay, let's follow a little bit this idea, the Haskell idea, and let's build an unfold unfold the M. Aha, requires traversable, which is what my intuition was. It might work also with distributive, but for now let's write it here, and let's say unfold co-free let's call it unfold M. Okay, and then what are we saying? Maybe we should have unfold underneath or nearby. And then maybe we should also have the code for unfold co-free, the Purescript code. Actually, I think I already had it here. I do. And that's the code for unfold co-free. And we can do this. So it uses Bianco free, and Bianco free is this. Okay. So does unfold look a bit like what we would expect? Unfold FC. Cases F with C. Oh, okay, hold on. Oh, I see. Right, so that's more like build. That's more build co-free. Yeah, at the top of a NFS. Okay, but that's fine. So we get an X and a D, which are basically the E and the N. Then we, in our case, build co-free, which in fact here differs because we want to use the lazy version. And then maps build co-free, so F maps build co-free K, which is unfold. So unfold F. Oh, so there's two maps here. Again, F map to the result of KS. So here we just take the X, which is our head. Oh, because here we're waiting for a B to be passed. Ah, yeah, same here. We're waiting for an S to be passed. So I think I think X is a function from B to A here, technically. Or S to A. If we say B is S, let's do that. And then we say yeah, we have an S to A, and so the X is the function of S to A. So let's call it SA. Or oh, but I'm using the K there. Yes, E applied to S, E being that thing, so that's more like E, and that's more like N. E, N. Did I get that right? I think so. And then you're just applying E to S. Are you F mapping? So that's the tuple. There's a top like build free map build free co. no, KS gets a tuple, yeah, and then this applies the thing underneath the tuple. Okay, I'm a bit unclear about that. I think maybe I should try to write unfold without using a build cofree, and that might help. So unfold with the en, and well, to be honest, I could also write a Haskell unfold that is using e and n directly, and then returning this, right? And then that would be S2A, S2FS, right? So then what I'm really saying is, well, yeah, I mean, we could defer, because otherwise, I mean, I think we need to do cofree defer. And then, yeah, then we're mapping unfold E. Oh, what? Hold on. There's something I'm not doing right here. XD, XD, EN, EN, but right, so yeah, okay, of course it's ENS, ENC, no. Yeah, it is ENC, and then here I think is EC, and NC. Right, I think. So cofree defer. And yeah, we need to do a tuple. Oh, so that's why you're building cofree here. Hold on, I need the mk cofree. Differ cofree. Yeah, you need to a tuple. Yeah, so a tuple of an A, and our A is going to be EC, I believe. So E, and we need to have the state here, and let's call it S. And then we wrap it with the F, and I think then it starts to look a bit like map, unfold, blah, and NS. Okay, we need to remove that. And we're missing a parenthesis. And we want, oh, we can't use that. We need to use differ cofree here. Yeah. And we need double constructor and this here is not right. So fmap unfold. Yeah, it's not. Hold on. Right. Yeah, it's unfold en, of course, right? I think apply to ns, but maybe that's not right, or maybe it's just applied to us. Could be that it's just applied to us. It's not. Okay, what do you want here? Go free f3, a4 with a4. Okay, let's try and do that. Okay, what do you want here? You want f0, go free f0, a1. That makes sense. And well, we can apply s to n, right? So let's do that. Then that gives us an f, right? Gives us an S, but yeah, it's not enough. I want to fmap unfold f. Onto n. And the whole thing presumably is just waiting for an S then. Okay. I mean, is this correct? Yeah, fmap unfold fd. Yeah. Okay, so I'm not sure. Maybe it's just. Yeah, maybe it's just this. Apply to S. Okay. But this is the same as this, right? This is but here, this is applied to D for some reason. Which is N in our case, right? So maybe that's the way. This I tried, right? Oh no, okay. And so I want to, yeah, right, my interpreter doesn't have the right type right now, but let's just make sure our unfold works. This, okay, compiled, and then let's make sure our unfold works. It compiles, and then let's try and see whether we can get things to work with counter and 2 exclamation points. Yeah, we can. Okay, so we can write an unfold, and then can we write an unfold M? and apparently we need, I think we can do this with distributive, but we can try with traversable. And then we'll want that same shenanigan. Ah, well, except it might be MA here, and S2 M FB, or S really. 2S 2M of co-free FA. I think that's what we want. And we want a traversable F, which is, I think, easy to do, but we'll need to try. And right, it's not an F here, it's an E, an N, and an S again. And right, so how does this work? Apparently we take the function f and we get its effects and its results. So that should be something like, oh, interesting. Yeah, I wonder if that means that each thing could have different effects. It might, and I don't know whether we can use that, but we're kind of means we're getting a E prime out of E, and N prime out of N. And then those are being passed to this crazy thing. Which is just X, which is E prime, which, so we'll need differ free here, and probably pure. We'll need to, we've executed our effects already, so I think now we can say, well, tuple of E prime S, and here we're going to try to do unfold, but we're going to need we're going to need unfold M. It's the map that's not going to work for us, right? We're going to do unfold M En apply to N prime S, but that's going to be saying no. Well, first of all, we need to import traversable. This is going to miss a bunch of FMSAB, or there's no B. And E is a function of S. Ah, right, okay. Yeah, so I need to do that, and then I can do that. But it's not a co-free. Why not? Differ co-free, blah tuple, E prime map, unfold M, En. But well, in theory, it's because of the M, but I'm not so sure. Yeah, you can't match M with co-free. Right, I suppose so. That's where we need to sort of do both map M and lift M in order to get our things in order. So I think we need to look at the types of both. In Haskell first. Ah, wow, that's cool. Hold on. Right, that's super specialized. Okay, package lift M. Let's lift M. Source is not part of the deal. And then we have the data traversable map M, which we probably best search for like so. Map M, we end up exactly in the same place. That's annoying, but that's just life. Okay, so let's try and find those in Purescript. We have lift M1. A to B, MA to MB. Yeah. So it's lift M1 for us. And so I think we want to we have a problem with tuple here, I think. Well, we need to fmap the tuple like so, maybe. No. We want to tuple E, and then we want to lift M1 this. Can we do that in Purescript? I think that's in Prelude, so should be okay. And then we need mapM, and that's probably not in Prelude. Yeah, so let's try and find it. Pipe traversable sequence, so probably not there, but let's look at Monad and see whether it's in the Monad package. Traversable is not here, so in that case it means that it's probably in the traversable package. And where is it going to be? 4 TA, an A2MB, and an M2TB. Yeah, it's argument flip, so it's traverse actually. Okay, so traverse then. By traverse, maybe we don't have data traversable in scope. We do. All right. What's happening now? So let's check we've done what we wanted to do. We've mapped them, the unfold. But it's flipped. Let's double check. A2MB. Traverse A2MB TA M2TB. Yeah, so that seems correct. Yeah, and then maybe we want to make this a proper lift M1. Right. Yeah, we need to do something with defer as well, actually. In fact, arguably, how is this going to work? Yeah, I wonder whether I can actually try to use regular build co-free here and see whether we can work it out. Something like so. You can't use lift M1 like this. So I think you need to do this and lift M1. I think that's right. But so liftem takes the x blah. Okay, let's not make this anonymous. Same problem. Liftem takes the A to B, A to tuple AB, let's call this X and T, just to do like in Haskell. Yeah, that's going to create some shenanigans here, but we, I think, established that the anonymous function worked in this case, maybe. And then we say en, and this is T. We do use fish here, though. It's slightly different than using... let's see if we have... if we could use fish. H1B. Could transform this into a tuple. Do we want to do that? Is there something different here at play? I don't think so, right? The F takes the B and returns in the M of AFB. So the X and the T gets into that, and then the X and the T get passed to this function. Yeah, no, I think it's just a point-wise version of it. But traverse doesn't work. And for them, blah. Ah, yeah, TS maybe. No, because I've applied E and N to S. Yeah. Taco free FA, taco free T of T to blah. Yeah, that's really strange. Oh, X. Yeah, no, that sounds fine. Oh, hold on. Now I don't need tuple. What am I doing? And now maybe I don't need to pure. Yes. Okay, so now go and fold M. And are you just going to work with this monad? You're not. But why not? Maybe because we want the effect to be around it, like so. In which case we don't have the right type, but I think we can massage this. And still not the right type. So render. That's not the render. That's the render, and that's not the right type here. So we need UI to be in effect as well in order to use this. Although, I mean, I could be a little bit creative here, right? I could say, well, one of these things is not stateful. So we just mean, or stateful, effectful. We just mean ES here and carry on. And we say n for prime, for them prime. That prime and then prime. And then, indeed, we need to be returning in effect now. But maybe that's just fine. Maybe just in effect. Except we don't have traversable for counter interface. But that's very true. That's very true. So we're okay with that. Show me traversable. And compatible with the foldable instead. Oh, do we need, is that, yeah, we need foldable for that. Did I try this before? I think I did, but let's try and write them nonetheless. It's getting pretty late. Let me make a tiny break and be right back. Okay, all right, we'll go for another half hour or something. How long have I been streaming? Way 3 hours. Okay, but look at this. We're doing the unfold that we wanted to do. So what's happening here? Oh yeah, we're doing the traversable instance. Excellent. All makes sense. So we need to do foldable first. Foldable counter. Going to be foldable count. Oh, it's interface really, but where what? Where fold map? Monoid of blah. Let's get an F and an A. Something like that, right? That being the case. And what would it look like? Well, our F is going to be our counter interface of things, right? Ah, yeah. So how we, if we have a function, yeah, okay. Counter interface of change count and increment. If that's what we have, then oh, hold on, and then we give it an F. That's our A. Then we are going to return an M, apparently, right? Oh, how are we going to end that? Yeah, good question. So we know how to take one of these. Oh, no, we don't know how to take one of these. We know how to get an F full of one of these. So a counter interface of A's. So interesting. Right. So the question is, how do we get an M out of that? This F is supposed to be full of A's, let's say ints, but in reality, because it's a base functor, we know that it's going to be full of some continuation in reality. But does it matter? Does this matter? I mean, the thing is, we need to choose one, and that's not very generic, right? Definitely not generic at all. So how's that work? It feels a bit like we should have like a get, and then fold map of the get would sort of make sense, whereas fold map of the increment wouldn't make sense. Okay, let's add a get. Yeah, and then say, well, actually, you're going to what are you going to do then? Well, we know that get has an A in it, so we just have to get, and then we say foldar equal foldar default and fold L default. And then we need to interpret get, which is identity, I think. Oh, well, yeah, okay. We need to return count, and that's it. And we now need still traversable, but apparently we have a foldable taken care of, so that's progress. And sure, it should be traversable counter interface and foldable counter interface, but it's okay. Those names are for error messages. Okay, so now we need traverse or sequence. What are the types? It looks like maybe we go for sequence. So sequence. You know what? Maybe we go for traverse. Let's go for traverse and see what's up. So in traverse, we have some F and we have a T of A, okay? And then, hold on, what is traversable in this case? It's the T that's traversable, right? So that's our counter interface here. So, let's do so. But now we want to get an M of the whole thing. So for sure, we're going to need to deal with change count and increment as well. I'm pretty sure. And yeah, so now we want to rebuild a counter interface. We want to do the effects of F. Okay, so something like we're going to apply F to all of these things, right? And there must be a pretty way to apply F to a record. I want to return in the M monad. So now we are supposed to be underneath TA. And we're going to want to rewrap things with the change count, all of these things properly updated to their values. So how's that going to work? Let's start with get. Let's say I have a function that, let's say that I know that, I know that we're in a do block. And that I'm going to return a pure counter interface with get in it, and we're going to have gotten a B from applying get to A. What am I trying to say here? No, from right. So from applying F to get, and then we get the B out of it, right? And that's, I think, the pattern. But yeah, so in theory we do the same with increment. So we call this GI, but then change count is going to be a little bit different, because change count is a function, and so we need, I think, to do this, and then do get increment and change count count C. Well, no huge protests. And if we say sequence default here, actually looks like we have an implementation. And then does for them prime. Hold on, where is the error now? Ah, no, yeah, okay, it doesn't work. Doesn't work because C should be a function int. And applying f to it like that doesn't work. Okay. So change count. So C is going to be a function. Which takes some int. And returns f applied to change count and x. And we're going to want to lift that. Maybe just doing lift m. No, I think that's not correct, actually. We're going to want to execute the effect of that. F has effects here. Oh, right, okay. Yeah, C is going to be equal to, it's going to actually be, actually, won't that work? No. C takes an x. I'm sure I'm overlooking something super simple here. Give me a monad, something, a monad, please. Okay. Function of a to x and an MA gives me an MB. Yeah, okay. So lift M1. A function from A to B is x to change count of x, therefore change count really. A MA is f. No. It must be class decomposition actually. But we want to see that is not effectful. What do we want exactly? We have an F that's an A to MB. We have a function that's like some C to A. And we want a function that's from C to B. And that's okay if it's an M. And that's the traversable instance for function. Is that right? Is there such a thing? Yeah, there's a function. Maybe not. Maybe not generically. Huh. I mean, this is right, isn't it? Like, what did I write? Show me again. A2MB, T being function from C to A. So no, so that's reader, actually. That's just a traversable instance for reader. Which we don't seem to have. I mean, not here, but maybe in reader. Reader has no traversable instance. So maybe it's about distributive. It has a distributive instance. And distribute will get us in the same position, I believe, right? It would be GA, yeah, I believe so. And distribute has, let's look at the other, well, yeah, function has a, and it's a prim. So let's try and distribute then. So how do we distribute? We say we distribute F over change count. And for that, we need to call data distributive. Yeah, it's yeah, okay. So you are going to need some kind of reader. I'm going to need to pretend that this is a reader. Well, I suppose maybe that's easy. I think I can just say actually, I think I might want an monad ask. Except I don't seem to have all of the instances I want for monad ask. Okay, maybe I'll implement it with the, maybe I look at the distributive instance for reader specifically. And so distribute prime. Oh, you know what? Just distribute. Let's remove the distributive import. Not a very clean way to do things, but so that's an F and some F, right? Distribute is, where is distribute? Oh, it's collect we wanted to apply. Okay, now let's try again. Okay, maybe we actually no, yeah, we need to do pure, right? Okay, so what, we're not in the right monad, how come? Is this because, it might be because of collect? Okay. That normally is like when you don't import prelude that you get this kind of errors. no type class instance was found for M3. And M3 is bound somewhere. Right. Do I need to say that something's a monad? I think it should work for any M, right? But it needs to be the same M. Yeah, but this should be just fine. So unless maybe collect is changing our type in a way that we don't want. So let's just look at collect again, make sure this is the type we want. Collect takes an A2FB. So here we're saying A2. Ah, right. Well, I mean, I think it's fine if our F is as an M. There's no reason, and it's a functor. And GB and GA, and then we're saying G is reader. And so some array to an M of some array. And that's what we want, right? That's what we wrote in our search, but let's look again. F is a A2MB. Change count is some function from an int to an A, some R to an A. And we want to go back to as a function of some R to a B and be able to get that out of a monad. So really this should work unless there's some types annotations that are in fact somehow needed here. Maybe if we put this up, what does this say? Variable T is undefined. Yeah, oh yeah, because that's now counter interface here and here. Yeah, this should work, but somehow it doesn't. Do I need to say that this is an M somehow? It should be an M of A here. The variable M is undefined. I think yeah, I'm not sure how this works. I thought this would actually work, but maybe we need to say this. No. How come? Yeah, I'm not sure why the M doesn't get there. Very unfortunate. I mean, can you give me a type for here? No, you don't even want to find a bind for this, which is so weird. Maybe it's just something simpler. Distributive for functor F. So maybe it's because we're not imposing M to be a monad. So make M a monad. There we go. And then you want a distributive for M. Yeah, sure, make M also distributive. which is going to create a problem because now we're trying to say that effect is distributive, which is probably quite wrong. Okay, you're now saying something similar, that you don't have a distributive instance for M, but okay, right. That's because those things should be in the type class, and therefore I think they need to be like so. But that apparently gets us back into the same predicament. Okay, do we need both? No. I mean, clearly effect is not going to have a distributed instance. Hold on there. Oh, I could make one. No, because, or could I? I don't know. And traversable, that also with, I suppose we'll have some trouble dealing with a monad M. I mean, it needs an applicative. I mean, all of this is because of collect, right? If I could just traverse this, then it would maybe work. Still not. That's the fact, again, like that's the fact that here we're supposed to make this work with applicatives. Oh, but hold on, I can make this work with applicatives. Yes, I see it now. Yes, yes, yes. Right, so I make that work with applicative by applying GIC to fget, and then up to f increment, and apt to traverse blah blah. And then I don't believe I need any of those shenanigans. And then yeah, we are missing a traversable instance for function, which is fair, but is it though? Can't we? Okay, let's Haskell traversable instance for. It's really reader. We can't write it for no such thing as unwrap. Is that the real problem here? Traversable instance for function from K is a map from just, okay, in unbounded K. I see. That's pretty. Oh, with if K is finite. I see. But int is not finite in our case, so does this mean we can't do that? Okay, do we reach back now that we don't have our problem with applicatives? Can we reach back to collect here, or are we going to need? Yeah, we then then we're missing a distributive instance for any m that could be put in there, and that's not gonna work for us, I don't think. But there's, well, we've said that there was at least there was a distributive instance for reader, right? For reader and what? Given G is distributive, reader E G. So, and is identity distributive? What's that? In, yeah, this identity is distributive. So, okay, we're back to defining maybe collect this time instead of distribute. But collect is f map something. Yeah, it's distribute map f blah. Okay, well, and then we might be stuck because of our because we'll need what? We'll need m. No, maybe that will work. Hold, let's try. Reader T. Okay, we need. I need the distribute type again. Distributive. Oh, we can do that. And here we're trying to say monad m. We're saying monad f in this case, aren't we? So let's say monad m. Let's put m in there and back. Trying to say that G distribute over M. G being what? Anything here? Hold on. The distributive F. Okay, hold on 1 second. Let's go back to this. So we're trying to say that we have a distributive reader which I think can legally be written like so, and that's an F. Oh wait, no, hold on. That's the other way around. F is our monad. Is effect. So I think I'm gonna have a little bit more trouble with that. We are trying to write traverse. Accumulating results and effects in some applicative function. And our problem here is that we don't know how to write traversable for function or for reader. See there, what does Haskell say? Haskell counts product. Yeah, pretty similar stuff. Yeah, if only it was just tuple, but it's not. Could we change this into tuple? maybe we could. Then I think it would mean that we write the co in a different manner, but I think there's an equivalence there. In which case, you know what? Let's try that. A tuple of int and a. And then I think we just have a traverse. Indeed we do. And then here change count, though we need an implementation. And now we're actually, what do? We return, we take C. And what do? We say it's not a function anymore, it's a tuple that returns an int. Yeah, so no, that's not gonna work. That is not gonna work. Maybe I'm saying this too fast. Hold on, because it's not going to work unless maybe if we have a change count co. Let's make it counter interface unit that actually takes an int and somehow knows how to interpret the passing of something into our change count. What did that look like before? Change count unit. Okay, but now we may be saying something different. What are we saying? We're saying change count is a tuple. Actually, I think this type checks, doesn't it? I think so. This is a tuple. Isn't it tuple count unit then? This one we need. Unknown value count I. And then we just say, so here we're supposed to return a counter model. Well, we're supposed to return a counter interface of counter model. So we could return tuple count and count C, or count. I think that's weird. I mean, it might work, but it's weird. Okay, hold on. So, right, so now we traverse works for pairs or tuples, so we fix that magically. But now we are, I suppose, right. So now we're basically saying that that we're in a monad here, and that UI really is explore counter of that, and then we render. Right, not exactly, because explore takes a right. So hold on. Yeah, we actually need to don't we need to do something like explore counter where maybe say explore UI and then we get the counter? And then yeah, change count doesn't work, but let's imagine that we don't have a change count for now. And then yeah, we have this weird thing going on, right, with this incredibly annoying bug. When you remember it, it works. Okay, so now are you telling me that I actually succeeded in adding potentially an effect in there? Nothing's happening here. Okay, that's good. I broke a thing. Actually, we are not out of the woods here. Right, because we haven't yet fixed this explore guy. And but to be honest, I'm not sure when I need to fix that component guy anymore, because now I've wrapped my whole component in an effect. So I'm separating when I'm extracting this effect from the loop, so it might not work, to be honest. This might display yo just only once, because it might display it just only this one time, and then that'll be done. It's probably what's going to happen, but let's just revert back to explore in a way where we don't do this crazy thing right there. So that would mean we just return this, I believe, like so. Yeah, and it seems to build. But it does break. And we also get an error. We get tons of yos, actually, including a maximum call stack size. Interesting. Okay, so okay, what's going on, we think, here? We get the counter out of the we get the UI out of the counter, which is in this effect. And I suppose it does have an infinite. It does have an infinite thing in it. So simply trying to express that monad. So yeah, that's right. We need to somehow distribute render or traverse render over our counter. So let's see if we can do that. Well, let's see if we can do that here. And let's look at traverse again. So render, well, In fact, our counter or let's say explore counter that's not going to work, right? I think maybe just sequence explore no. If our components are traversable, could pass it to the Kleisli, but our components are I suppose that's the difference here, and it could be that we want our component to have a base value in effect. That might work by saying counter interface off. No, that might actually not even work. Yeah, there's something about the laziness of the traversable here. I think so, right? Purescript, lazy, traversable. Okay, but that's because lazy list implements traverse and traversable list here. Which, interestingly enough, doesn't seem to be doing anything, though unfoldable does something with the fur. But interesting. I wonder whether this is something I'm looking for. What is unfoldable? Maybe it is closer to something I want. I don't know. I mean, doesn't solve my unfold M problem, but I chose traverse here. I mean, that's the other area where I could introduce some laziness here, possibly. Yeah, right, I could defer here instead of, I suppose. So how would that work? I will need to for co-free. It takes a function from A to B. I want to return, or do I want to return an M co-free FA here? Is that really the goal? I'm not so sure anymore. I mean, if laziness works out well, then sure, we can pull that off and say we'll execute the effects as they come. But it's not clear. Takes a JSX, an element, turns into effect unit. Okay, well, I'm going to wrap up here. Let's write down what we did today. We haven't moved back to the class pairing, but we're working on making the effectful interpreter. We're trying to return something like effect React component, I think. But really what we did was to use this, which is an effectful interpreter, and we used unfold M prime. Oh, yeah, some unfold M, right? Unfold of co-free component from a seed used unfold M from Haskell. But that didn't quite work out, probably because of the laziness again. It's just that maybe, and it could be that it's just a JavaScript thing where, and I thought about that actually, that could be just a JavaScript or Node thing where actually we need to free up the event loop somehow. I forget how you do that, like say timeout 0 or whatever. So that's possible that this is the problem here. I would have been expecting that also, or maybe it's because we need to be in AF as well. So that's another way that another thing we could try. Sounds weird though. Sounds like this should be interpreting only when there's a change, but it seems like it's not. And probably because when we did this this code that worked, the UI to counter, then we're trying to unroll the whole monad. So is too eager. Can we make it lazy? So that's where I'll stop now. That seems like some movement back towards trying to make it effectful interpreter work. Definitely went down and was able to make the program compile. We get some Stack Overflows, but they're not unexpected. That's pretty much where I would expect to be. And you know, adding unfold M, in fact, to the co-free, to the Purescript free module might be something interesting. It's not monadic. Yeah. So we could submit unfold them to Purescript free. Should we submit unfold them? To Purescript free. Okay, so that's it for now. Thanks a lot for watching. Enjoy your weekend, and I'll see you on Tuesday for more towards trying to make Effectful Interpreter work. I think this is definitely closer to where I want to be in terms of where I want the effects to show up. So hopefully we can tweak it to make it work. I feel like there's progress. So thanks a lot and see you later. Bye-bye.